Saxon Algebra 1/2. You can tell when I put my own version of the title because they don't sound like John's. John's, I'm not even going to tell you what his is, but I am calling this multiplying lots of fractions. I mean, by lots, I mean 3. But these problems are ever so slightly more complicated, but not a lot. Let's dive in. Example 22.1. We are going to multiply together 3 fractions. And I'm going to give myself lots of room between them because we're going to be doing some work. But I have 56 over 27 times 14 over 21 times 15 over 22. Now, we know that when you multiply fractions, you go straight across the top, straight across the bottom. That's easy. So, all we would have to do is multiply 56 times 14 times 15, and then 27 times 21 times 22. Guess what? I don't want to do that. Those numbers are way too big, and I don't want to get some giant fraction out here and then try to figure out whether or not we can reduce it or not. That sounds like a nightmare. I would always rather make my numbers smaller before I need to make them bigger. So, what we want to do here is what we call canceling before we multiply. Essentially, we're going to reduce these fractions against each other instead of creating some big monster over here. So what we're looking for is factors of any of these numbers that can be canceled top and bottom. Remember that we can cancel in different fractions any way we want, as long as we are canceling one of the numerators against one of the denominators. You can't go top to top or bottom to bottom. All right, so where do you want to jump in? There's so many options, you guys. I wish you were here and you could pick for me. The one that's driving me, it's like screaming and jumping up and down in front of me, is this 14 and 21. I know my seven times tables well enough to know that 7 times 2 is 14, and 7 times 3 is 21. So I can divide top and bottom by 7. When I do, I have 2 left here and 3 left here. Please notice the way I am crossing these out and writing the remaining factor against them, okay? That's super important. All right, what else can we do? Well, how about the 3 and the 15? 3 goes into 3 and 3 goes into 15. So here that changes to a 1 and that changes to a 5. All right, I feel good about it. Do you? I see the 2 and the 22, and I know that 2 will go into both of those. So this becomes a 1. This becomes an 11. All right. Notice that I'm trying to keep this crossing out thing neat because it gets really confusing. This one's done to a 1, so I'm going to circle it because I know I can't do any more. That I can't do anymore. 5 is prime, and I know it won't go into either of these denominators. So I'm going to circle that. That one's done. And this 11. 11's not going to go into 56 or 5, so the 11 must be done. So all I need to do is go over here and think, is there anything that goes into 56 and 27? I'm not sure, so what I'm going to do is make a little prime factor tree and look and see if they have any branches in common. 56 is 7 times 8. 7's prime. And then 8, I've done enough times that I know 8 is 2 times 2 times 2. So there are all the factors of 56. I'm just going to cross that out so it doesn't confuse me because those are the prime factors. And then 27, I know, is 3 times 9, which is the same as 3 times 3 times 3. All right, so this is some 2s and a 7. This is all 3s. Those guys don't have any factors in common. So that's another way I can be sure there's nothing more we can reduce. So now all I need to do is multiply across the top. And I can multiply these in different order. I could multiply 56 times 5. Or I could look at this and see if there's an easier way to do that. So I'm going to write them down here just so you can see them. I'm just doing them in my head. It's 2 times 2 times 2 times 5 times 7. Okay, this is 10. 2 times 2 is 4. 4 times 7 is 28. So I can see that this added together equals 280. I could have done that just by going 56 times 5. Let's just look and see how that works. 325, that works too, right? We get the same answer. So whichever way feels better in your brain is fine with me. I like to show you different ways so that you can see you have options. And whichever way your brain feels more comfortable doing, go for it. All right, so we've got our denominator down. We know we can't do anything more down here, so let's find our denominator. It's 3 times 3 times 3 times 11, and we already know that's 27 times 11. So let's go 27 times 11, and that is like that. And that is our denominator. So this is our final answer. And because we were careful with our factoring, we know it's already as simple as it will possibly be. And that's the end. That's the right answer too. Let me just double check. Yeah, that's right. Okay, so the nice thing about this process is that if we're careful here, then we don't have to do anything more to that. And there's just one more problem in this lesson. Example 22.2, I love all the twos. Simplify. I'm going to write the problem as it exists in the book and then tell you what I would recommend you do for your homework. 26 over 30 times 21 over 39 divided by 4 over 15. That divided line sounds in my head like a needle on a turntable skipping across the album. You know, like... This gets my attention really fast, and I know that's drama. So the first thing is to figure out, well, what kind of drama does it cause? Well, the way division signs work is that everything on this side of the division sign stays the same. 26 over 30 times 21 over 39. Now, when we get to the division sign, we know we want to change that to multiplication, and we want to flip the fraction. Oh, I used up my space. Now I'm writing the wrong thing. Oh, I'm so flustered. We change division into multiplication, and we flip the fraction. Okay? When we get to studying complex fractions, you'll understand more about why this rule works the way it does. There's a really cool thing that happens. There's a step in between that I'm not showing you that helps you see why dividing by a fraction means the same as multiplying by its reciprocal, but I'm not going to confuse you with it now. Right now, I just want you to trust me and know that in the middle of next year, we will talk about why that is so. All right, so now, other than the fact that that's a mess, I am ready to do some canceling. All right, what do you see that you'd like to cancel? Well, I see the 15 and the 30. And I know that 15 times 2 is 30, right? Because 15 is half of 30. So I'm going to cancel this one and make it a 1. And I'll circle it because I know I'm done. You can't reduce anything more there. And then this becomes a 2. All right? You might get excited and go, oh, 2 and 4, 2 and 4. Can't do that. They're both on the denominator. So let's go 2 and 26. 26 is an even number, so it must be okay. That makes this a 13. And this now is reduced to 1. Beautiful. What else can we do? I want you to look for a minute and think about it. This is where knowing your times tables really helps you so much. I'm not one of those people that likes to shame students over not having their times tables memorized. If you know how to figure them out, that's just fine with me. But if you know them by heart, your work will be so much easier. So work on that. 13 times 3 is 39, right? 3 times 1 is 3. 3 times 3 is 9. Ooh, let's cancel. This becomes a 1. This becomes a 3. All right, so let's see what we've got. This is all 1. That's a 1. So we have 21, 3, and 4. Do either of these Denominator factors go into 21? Yes, 3 does. It goes in 3 times. It goes in once there, and it goes in 7 times there. Now we're done because the only numbers we have left are 7 and 4. And that's the fun of these, is when they reduce down to a nice cute little fraction. That one we did before wasn't very satisfying. It was what, 280 over 297? Ew. But this one's cute and I'm happy. So most students, once they get the hang of these and this division trip isn't freaking them out anymore, find these kind of fun because it's fun to take these big ugly things and find all the canceling. That is all there is to lesson 22. It's fun with fractions, guys. I enjoyed it. I hope you did too. And I wish you all the best in your homework, which, by the way, is exactly what we did. The first one is just multiplication. The second one has a trick division in it. So remember, everything on this side of the division sign stays the same, and then we flip the one that comes after. Beautiful. Done. Have fun. Goodbye.